In today's lesson, we're going to be talking about a very important topic, and this is our discussion on factoring polynomials. We're going to spend quite a few days working on factoring polynomials, and days might actually stretch into weeks because it can get pretty complicated, especially if you do not master the early steps that we're going to be talking about today. So, we're going to just take this really slowly. And to get started, we're going to do some warm ups. So, we're going to do some multiplication. And find the product certainly implies we're multiplying, and then seeing two parentheses written next to each other implies multiplication. So we definitely should know, hey, I should multiply these things together. And so we're going to use the FOIL method or the distributive property method, however you want to think about it. And so I do x times x, and I get x squared. I do x times 10, I get a plus 10x. I get a 1 times x plus an x, and a 1 times 10 and get 10. And then you can see we have two middle terms that can add together, a 10 and a 1, which makes 11. So x squared plus 11x plus 10. When we multiply two things together, each of those things is also known as factors. So we have multiplied two factors together, and we got our trinomial. I'll do part C next. We're going to again do FOIL. X times x is x squared, negative 3x minus 5x, and then a negative and a negative makes a plus 15. Anytime the signs are the same in your binomials, it'll multiply together to be a positive number on the end, of course. And since both of these signs are the same, the negative 3 and the negative 5, we're going to combine those together, and it's going to look like addition, right? So it's going to be negative 8. 5 and 3 make 8, so it'll be a negative 8. X squared minus 8x plus 15. So those two factors, x minus 5 and x minus 3, multiply together to be that trinomial. And then this one is also a product. These are also factors. We have one thing times another. So this is factor 1, 2x's, and 3x minus 5 is factor 2. And this time we're just doing a single distributive property instead of 2. So I get 6x squared minus 10x. All right, so that's multiplication. We multiply factors together, and we get a number, or in this case, a polynomial. And so what we're going to be talking about today is the exact opposite of that. We're going to be talking about what's known as factoring. So when you're being asked to factor something, you are being asked to figure out what things multiply together to be the thing you're factoring. And so we're being asked to factor on this one, 6x squared minus 10x. And we know, because we've done this already, that we could look to see if there is a greatest common factor that we can factor out. And so I look at 6 and a 10, and I know that they're both at least divisible by 2, and I don't think anything bigger. And I also see that they both share a times x. One's got 2 of them, one's got 1 of them. And so they both have a 2 and an x in common. And so what would I have to multiply 2x by to get the rest of this? Well, the 2 times I'd have to have a 3 here. And to get x squared, I'd have to have an x. And then minus, and I'd have to have a 5 and no more x's. 2x times 3x, 6x squared, check. 2x times negative, check. 10x. So this is the factored version of this. All right, so then we go to part D, and I say, what are the factors of this one? Well, we can clearly see that there are no common factors. So I can't do what I just did on C. I can't just pull a number out or a variable out because they don't share anything in common. So on one hand, we would say, oh, this doesn't factor. But we know this factors because not more than a minute ago, a little bit longer because I talk slow, we just did this problem. Notice we just multiplied on part A, we just multiplied two polynomials together, two binomials, and it equaled x squared plus 11x plus 10. So by definition of what factors are, if I ask you to factor x squared plus 11x plus 10, it has to equal x plus 1 times x plus 10. So the answer to this question would be x plus 1 and x plus 10. Clearly, having not just done the problem, it would have been harder to know that answer. And in fact, probably many of you would struggle to figure it out on your own because we haven't taught you a method yet. So that's what we're here to teach you today, is a kind of a foolproof way of factoring a trinomial into two binomials. All right, so let's get started. The very first step, well, first let me back up. So today we're just going to break it down, and we're only going to be talking about trinomials in this form. And then specifically what we have here is we're going to have no number in front. So it's always going to be x squared, not like 2x squared for today. And then we're also going to be looking at ones that have a plus a constant on the end. So plus c and a plus c. So everything we do to get today is going to be based upon this format. The middle term could be a negative or could be a positive in our examples, but everything else will stay the same. The x squared and the plus will stay the same. And if I just quickly scan through, you can see that to be true. They're all x squareds, and they all have a plus 1, a plus 3, a plus 3, plus 5s, plus 14, plus 15, etc. Okay? So that's what we're doing today. On the next lesson, we'll look at what happens when it's a minus c. But for today, we're good. All right. So the easiest way to do this is really step one. And these are going to be informal steps. But step one is as easy as it comes. We're just going to assume that it will factor. Assume it factors into two binomials. And so what we're going to do is we're just going to put a set of parentheses, two sets of parentheses. So under our problem, we're going to assume it's going to answer. And if it doesn't, we'll just scratch this out or erase it. But to get started, we're going to assume that it will work. All right, so that's pretty easy. Step two. Well, hopefully we recognize that in doing the FOIL method. So let me back up. While we're doing factoring, always keep FOIL in the back of your mind, because whatever we place in these parentheses when we FOIL it back together should be what we started with. So the only way to have this x squared right here and to make the rest of this work is to have an x and an x in the front too. So step two, place x's in the front of each parentheses. I'm going to call it a binomial, but we're talking about those parentheses we just wrote down, binomial. All right, and if we just do the first step of FOIL, which would be take x times x, we see we get x squared. And that's why we put the x's in. All right, the next step, there's kind of a step 3 and a 3a. I don't really know which one we should really talk about first. I would say I'm going to call step 3, but later on, once we kind of know what we're doing, I'll probably consider the next step first. But for now, I think it's important we talk about this. So how do we get a 1? So, right, when we do FOIL, right, we do x times x, and we get that answer. We're going to do x times something here, and that's going to be something x. And then we're going to take this number right here, and we're going to do number times x, and we're going to get another something x. But the last step is we're going to take this times this, and those will both be numbers. And so if we know that number happens to be 1, right, then what we're looking for in those two locations in the back of each of these parentheses, they have to be numbers that multiply to be 1. So I'm going to say on step 3, find numbers that multiply to be the C value. Okay, if you check out kind of how we wrote the rule here, we've got plus C and plus C, right? So they're all of this form. So in other words, we're talking about the constant. Sometimes, like it is in this case, there will only be one option. The only way we could do it is if it's 1 and 1. But on others, you will see that there might be lots and lots of options. Okay. Before we move off step 3, we kind of need like step 3b or whatever, right? So we'll call this 3a and 3b. And I want you to think about the fact that we have a positive 1. In all the examples today, again, remember we're talking about where the C value is positive. The only way that that's possible is when I multiply this number I finally decide upon and this number I decide upon is if those numbers are the same sign. Because if it's a positive number times a positive number, we would get a positive here. If it was a positive number times a negative number, we would get a negative right here. So that would be impossible when we have a plus c. So I know for these problems, again, just these where it's a positive on the end, the signs have to be the same. The signs in my answer, in the binomials, the signs in binomials must be the same. They can both be positive or they can both be negative, because a negative number times a negative number equals a positive number. So at this stage, with the analysis on the plus 1, we know one of two things. It either has to be a plus 1 and a plus 1, or a negative 1 and a negative 1. Those are the only two ways I can multiply to get 1 unless I'm dealing with fractions, and we are not going to deal with fractions. All right, so let me erase some scribbles here. All right, so back to the original. I know it has to be x and x, and then I look and I say, okay, what are my numbers that multiply to be 1? I'm going to make a list. In this case, it's a very short list. So if this works, and again, remember this is all with the assumption that it will work. So I'm going to keep saying if. If this works, then it will have to be a 1 and a 1, and it'll have to be the same sign, and they'll both be plus. And the reason they're both going to be plus is because of this sign right there. And let's take a look why. Let's FOIL our work together, see if it works. X times x is x squared. X times 1 is simply plus 1x. 1 times x is plus another x. And 1 times 1 is 1. When I add x plus x, I get 2x, positive. So the only way that could be a plus 2x is if both of the signs are positive. Notice it worked. We were able to multiply our two, what we assumed the answer would be, together, and we did in fact get our answer. All right, so step 4. Find the numbers that multiply to be factor c. Another way to say that is find the factors of c, right? So then step 4 is see which factors of the c value add to be the b value. Or another way of saying that is the middle number. So I looked at the factors of 1, and if I look at all the options, and again, there's only one set, if you can add 1 plus 1 together and get 2, and that's a 2, then this will factor. Okay, and why is it add together? Because look at what happened once we FOILed out what we thought the answer to be. I got a plus 1x and a plus 1x. 1 and 1 makes 2. All right, talking it through slowly, I think it makes it seem complicated. This is actually a very simple process. Let's go through it on question B. Assume that it factors. Throw in my x's in the front. Find the factors of 1. There aren't any, but just the one option. And then ask yourselves, do they add together to be the 2? And the answer is yes. But this time we need a negative 2. So the two signs are still going to be the same because we still have a plus here. So instead of putting a positive 1, which would lead me to the answer over here, we need it to be a negative 1 and a negative 1. And we're done. Let's check it. I get x squared. I get, when I multiply the outside, I get negative 1x. When I multiply the inside, I get negative 1x. And a negative is a positive 1. X squared minus 2x plus 1. So it worked. I keep putting boxes around the wrong thing. Like, that's not my answer. My answer, of course, is the binomials here. So actually, let me just highlight that. This is my answer. We were being asked what multiplies together to be this thing, and we have found that it is these two sets of parentheses. All right, so let's keep going. Part C, assume that it works. Throw in my x values in the front. Recognize that it's a positive here, and I know that means my signs are going to be the same, and they're both going to be plus. So plus and plus. I'm looking for factors of 3 that add to be 4, and good news, we have some, 1 and 3. Doesn't matter which order you put it in, x plus 1 and x plus 3, or x plus 3 and x plus 1 should all still multiply together. Quick check, x squared plus 3x plus x plus 3, 3x and x make 4x. We're good. And you'll notice I'm following a pattern here, showing you one with a plus 4 and one with a minus 4. So again, what's the difference? Very little. Assume it works. Put in your x's. Find the factors of 3. Do they add to be 4? Yes, they do. But this time I need it to be a negative 4. The only way that's possible is if I'm doing negative 1 and negative 3. Still multiply together, be positive 3. But add to be negative 4. So you can think about your signs over here, or you can put your numbers in and put your signs in after. It's either way, it's the same. I'm not going to check this one, but well, maybe I will just real quick. X squared, negative x, negative 3x, plus 3. Some of you are going to ask, well, why are we looking to add to be 4? And the answer to that is right here. Because when I do FOIL, it puts them in right here. A negative 1 and a minus 3. We combine the 1 and 3 and get 4, and the answer is negative. So that's why we're looking for numbers that multiply to be 3 and add to be 4. All right, let's keep rolling. Assume it works. X and X. Only one choice, 1 and 5. Notice I'm ignoring the 6. The 6 is not where I get my options from. I'm focusing on the 5 because whatever I pick has to multiply to be 5. So that's going to be the smaller number of options. In this case, only one option, 1 and 5. Does that add to be 6? You bet. 1 and 5 goes in. Again, signs are the same because of this. This tells you what they both are. And therefore, they're both going to be plus. This one, again, same basic question. We're going to get off of that in a second. It's going to be an x and an x. Only way it's going to work is if we have a 1 and a 5. It's the only way to get 5. This time I need to add to get a negative 6. So we're talking a negative 1 and a negative 5. Check our math. X squared minus 5x minus 1x plus 5. This adds together to be negative 6. So we're good. A side note, if I'd asked you to factor this question, x squared, let's say minus 7x plus 5. Well, we would do our thing. We'd assume that it works, and we'd say x, and we'd say x. Only way we can get 5 is 1 and 5. Does 5 and 1 add to be 7? No. So when you follow the rules and they don't work, number one, double check you haven't screwed anything up and you tried all your options. But there is no way to multiply two numbers together to get 5 and then add those two numbers to get a 7. So that means this would not factor. So we would scratch off our attempt and we'd declare, not that we skipped the problem, we wouldn't leave it blank. We would say you cannot factor. Probably a better way of answering that, being a little bit. Anyway, what else? Yeah, so don't force. If the numbers don't work, the numbers don't work. All right, let's move on. All right, so now we're going to go on to, I almost cautioning about even calling these harder problems because they're not harder. It's the same thing. The only difference you'll notice is when I look at the factors of 14, suddenly we might have a couple, right? So it's not a given that it's the only option because now there's a couple of options. This doesn't change a thing. Assume it factors, put in my x and my x, and then list, and I want to see this list, 1 and 14, and be organized about it. From 1, go to 2. It's an even number, so 2 will go in. So 2 times 7 is 14. 3 doesn't go in, 4 doesn't go in, 5 doesn't go in, 6 doesn't go in. We're back to 7, so we've tried them all. These are my only options. So I'm looking for the factors of 14. Now there's 2 possibilities, either this one or this one. They both multiply to be 14, but they do not both add to be 9. So if I pick the wrong one, it's not going to work. Okay, so I'm going to pick the 2 and the 7 because the 2 and the 7 add to be 9. I need it to be a negative 9, so the 2 and the 7 that I plug in are both going to be negative 2 and negative 7. Check the math. X squared minus 7x minus 2x plus 14. Those combine together to be negative 9. Everything works. We are factored. Part H. Assume it factors. Throw in your x's. 1 and 15. 2, no. 3 and 5. 4, no. We're done. Those are the only choices. 3 and 5 add to be 8. So I need the 3 and the 5. Signs are the same. We know they're both going to be positive, or else I wouldn't have a plus 8x. Check the math. X squared plus 5x plus 3x plus 15. X squared plus 8x plus 15. Now, I do want to encourage you really strongly to check your work for the obvious reason that you know if you got it right. But even more than that, it really solidifies when you do the FOIL here. It really does solidify in your brain the connection of what we're doing to FOIL. Why are we picking the numbers we're picking? Why are we putting them where they are? Why are the signs the way they are? The answer all comes down to because FOIL is how we multiply. And so we have to keep those things in mind as we're unfoiling. All right, next up. Assume that it factors. X and X, 1 and 20, 2 and 10, no 3, 4 and 5. Which of these add to be 21? 1 and 20. So I'm going to, and again, it doesn't matter which one you put first. If you swap those places, it still will work out. And we can see that with x squared plus 20x plus x plus 20. 20x and 1x gets our 21x. All right, next up, part J. Assume it factors. X and x, signs are the same. I know it has to be plus and plus. 1 and 30, 2 and 15. 2 and 15, like you could subtract to be 13, but we're not subtracting here because our signs are going to be the same. So we're looking to add. And so that's not our answer. But 3 times 10 would be our next one, and 3 plus 10 is 13. Multiplies to be 30, adds to be 13. 3 and 10. All right, I think I've got 2 more. Assume it factors, put in my x's. 1 and 25, 2, 3, 4, 5 times 5. 5 and 5 make 10. So 5, 5, my signs are the same, but they're both going to be negative this time. Side note, notice this is one of our shortcuts. If I have x minus 5 times x minus 5, I can just square x and get x squared, square 5 and get 25, and then x and 5 multiplied together and doubled makes negative 10. Had you noticed that that relationship was in place here, we might have been able to get this answer faster. But side note. Okay, next up, last one. X, X, signs are the same. And they're both this one. So negative and negative. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Which ones add to be 15? if any, and we do have some. We have 3 and 12, 12 and 3. The order does not matter. Again, they're both negative because a negative 12 and a negative 3 makes plus 36. All right, so that is it for today. Again, this is meant to be easy. Next lesson will be when it's a negative. And then once we get really good at that, then we up the ante quite a bit and we put a number in front of x squared. And then that just makes everything about 5 times harder. But if you can do the easy parts, then we should be able to survive when it gets harder. All right, summarizing what we've done today. When the constant term c is positive. So again, what is that talking about? That's talking about something in the form of equals ax squared plus bx plus c. So this is a standard trinomial form. So we're talking about only on these problems when c is positive. Okay. The sign in the binomial is going to be the same. So it's either going to be plus plus or minus minus. But they'll both be whatever the middle sign is. So we look at b, and if it's a plus b, then we're going to have plus and plus. When it's a minus, we'll have minus and minus. Finally, when we have that positive c, that constant's positive, we also know that we're looking to add to get the b value, just like we did. All right. Hopefully this makes sense. Practice, practice, practice. And you should never forget this.